Welcome to the channel. Subtractor using op-amp is given. Sinusoidal signal, which is varies from 0.5 to minus 0.5 applied at inverting terminal. The voltage is VI, and which is AC. The voltage at non-inverting terminal 0.5 volt, which is VC. And we have to find out in this case the nature of output waveform. So I'm drawing the same circuit here and label the resistance. So negative feedback always used in amplifier application. Here two resistances at non-inverting terminal. So this circuit is also called as differential amplifier. Say this voltage is V1, this voltage is V2, this voltage at this node VA, and this voltage at this node VB. R1, this is R2, R3, R4, this is output. Op-amp has dual supply plus V minus V. So this circuit is nothing but subtractor or differential amplifier. The output voltage will be the difference of two terminals V1 and V2. In this case, we are taking R1 is equal to R2, and that is given 5 kilo, and R3 is equal to R4, and which is given 10 kilo. Why we are taking the R1, R2 equal or R3 and R4 equal? The reason is for CMRR. CMRR is nothing but common mode rejection ratio, which is the ratio of differential gain to the common mode gain. In order to get the correct results, subtraction of two signals, we need to reduce common mode gain so that we are getting maximum value of CMRR, common mode rejection ratio, which means that we are getting the good results of differential amplifier, good results of difference of two voltages V1 and V2. And that is the reason we are taking R1 is equal to R2 and R3 is equal to R4 in the subtractor. So here R1, R2 5K, R3, R4 10K. Let's start the solution. VA voltage we can calculate using voltage divider rule. The voltage VA is nothing but R3 divided by total resistance R3 into the voltage at non-inverting terminal V2. We are applying the voltage divider rule at non-inverting terminal. The VA voltage that is equal to R3 resistance divided by R2 plus R3 into total voltage V2. See, this is equation 1. According to the virtual ground concept, VA is equal to VB, which means that the potential VA is at non-inverting terminal. The same potential will be maintained at inverting terminal, that is VB, and therefore VA is equal to VB, maintaining the steady reference potential without connecting to each other. We are assuming VA is equal to VB. VA is the potential at non-inverting terminal, and we are assuming the same potential at inverting terminal VB. So there is no physical connection, but this is assumption. The same potential will be maintained at inverting terminal like VA, and therefore VA is equal to VB. Now apply the KCL at inverting terminal. So I am drawing the resistances. This voltage is output voltage. This resistance is nothing but R4. This resistance is nothing but R1, and this is V1 voltage. This voltage is VB voltage, and we know that VB is equal to VA. This is incoming current, this is outgoing current. I consider this node, so incoming current that is equal to outgoing current. So apply KCL. I uploaded video regarding KCL and KVL. If you don't know how to apply, please go through the video. I'm providing the link in the description box. V is equal to IR, simply we are applying. So here voltage V1 minus VA divided by R1 resistance. So I is equal to V by R. This is incoming current, which is equal to outgoing current. VA minus V0 by R4. So after solving, we have to put now the VA value from equation 1. What I did first, I took the value of VA by using voltage divider rule. Then I used virtual ground concept. Now I am applying the KCL at inverting terminal. Now in this case, we have to put the value of VA from equation 1. And after solving, we are getting finally output voltage, which is equal to R4 upon R1 into V2 minus V1. So V2 is the voltage at non-inverting terminal and V1 is the voltage at inverting terminal. Consider the first case. Here we have to consider the only amplitude. We don't want to focus on the frequency of the signal, since the inverting input is AC and non-inverting input is DC. So we don't want to work on the frequency of the signal. We have to focus on the amplitude of the signal. Please be noted. R4 upon R1, which is equal to 10 kilo ohm divided by 5 kilo ohm, which is equal to 2. So value of R4 by R1, which is equal to 2. To calculate the output voltage for first half sinusoidal signal, V0 is equal to R4 by R1. R4 by R1, 2 into V2 value is given 0.5 DC voltage. I am considering half sinusoidal signal. This is again 0.5. So 0.5 minus 0.5, we are getting 0 volt. So for half positive sinusoidal input, I am getting output 0 volt. Second case. Now consider the negative half cycle. R4 by R1, 2. V2 value is fixed 0.5 minus the value of negative half cycle minus 0.5. So minus minus, this will be plus 0.5. 0.5.51. So we are getting 2 volt. Third case, calculate the reference line to draw the sinusoidal signal. R4 by R1, 2. Input voltage for the reference. Consider the DC voltage 0.5 minus the reference voltage is 0. So I'm getting reference line at 1 volt. Here we are working on amplitude only, so frequency will not change. Input sinusoidal signal, which is applied at non-inverting terminal, and gain of the non-inverting terminal is negative. So we are getting the inverted version of the input signal. So first draw the inverting version of sinusoidal signal. This is because the input sinusoidal is applied at inverting terminal and gain is negative. So first of all, draw the inverted version of sinusoidal signal. For the reference voltage V0, what is the output voltage we are getting? Third case, this is 1. And for the positive half cycle, we are getting the voltage here, which is 0. The first case. And for the negative half cycle, we are getting the voltage, output voltage, which is 2. This is 2 volt, this is 1 volt, and this is 0 volt. So this will be the nature of output signal. Because of the negative gain, we are getting inverted sinusoidal signal. For the reference 0 volt, third condition, we are getting 1 volt. For the positive half cycle, we are getting 0 volt. And for the negative half cycle, we are getting output voltage 2 volt. So this will be the nature of the output voltage of this subtractor or differential amplifier. Thank you.